Hello and welcome everyone. Today we're focusing on Cambridge IGCSE Mathematics, topic of algebra, subtopic of simultaneous equations. So to start off, we're going to look at what are simultaneous equations. So basically, when you have two equations with two unknown terms, that is what we call simultaneous equations. Okay, so let's say you have x and y, a and b, and then you have two equations which link those two variables together. So using the equations, you can then solve for the two letters. That is the purpose of simultaneous equations. And there's actually two renowned methods that we use. One is the substitution method and one is the elimination method, both of which are very, very crucial for examinations and actually future use in our day-to-day life. So to start off, we're going to look at substitution and how this goes. So substitution method is generally used when you have expressions like this, where it is easy to rearrange this expression in the form of, say, y equals or x equals to something. So in the substitution method, when you have two equations, if you have one equation which you can rearrange in a way that you can substitute it into the first equation and solve, then it'll become easier. So in this case, you can see you have two equations, right? You have 3x plus y is equal to 19 and you have x plus y is equal to 9. Now obviously the second expression looks a bit more simple, and that is the one I'm going to rearrange. And what am I rearranging to? Well, I'm rearranging to y equals 9 minus x. So basically I have just taken the x to the right hand side using normal algebraic rules, right? And then what I do is I take my first equation and instead of the y, I'm going to replace it with this expression I have found now, 9 minus x. And by doing that, I can then solve for x, because now I have removed the y out of the equation. It's just a normal simple linear equation where I can solve for x. So by doing that, in the next line, what I'm doing is I have subtracted the x from 3x and got 2x, and I have moved the 9 over to the right hand side so that I have 2x is equal to 10, and then I can divide both sides by 2, resulting in x is equal to 5, right? And finally, that is not the end of the problem, right? Now that's a very common mistake that most students make, which is they forget that they've only worked out the answer for x but not worked out the answer for y. So what you have to do is then take that initial expression that you rearranged, y equals 9 minus x, or you can take this version of the equation also, it doesn't matter, but ideally the rearranged one is just easier. And instead of this x, you have to substitute the value you found so that you can obtain the value for x. And this is a must. In any simultaneous equation question, you must provide the answer to both the unknown variables, both x and y, or a and b, or whatever two letters are involved. Now, if we move on and see the other method, which is called elimination. So in elimination, what the purpose is to, again, what we want to do is basically to cut off one of the variables so that we can simplify and solve. And to do that, what we ideally do is we figure out if we need to multiply or usually multiply which equation, so that the number in front of either the x's are the same or the number in front of the y's are the same. Okay, so basically we want to try and make either the numbers in front of the x's the same or the y's the same, right? Now in this case, what they're doing is they're taking the first expression and multiplying it by 2. So when I multiply that by 2, I'm getting 4x negative 2y is equal to 14. Now remember, when you are multiplying by a constant, you have to multiply both sides of the equation, not just the left hand side, right? That's a problem. You have to multiply everything through. And once you have multiplied, the next step is to basically, you have to, now that you have both of these as 2y and negative 2y, you can actually cancel that term off. And how can we cancel it? If I add the two equations. So if I just write the two equations on one on top of another, if I add these two equations together, you can see that 4x plus 3x is going to be 7x, and that 14 plus 7 is going to be 21, and the negative 2y positive 2y is going to cancel off each other. So therefore it results in just a very simple expression, 7x is equal to 21, from where I can solve and get my value for x as 3. And again, that doesn't stop there. You have to take that value, put it back into one of the equations, find out the value for y. If you want to be double sure, you can even take the second equation. Now in this case, they have substituted into 2x minus y is equal to 7, right? And they have obtained the y value. If you want to be double sure that what you have done is correct, you can substitute your x value and your y value into the second expression and double check and see whether that equation holds. And in this case it does, right? 3x plus 2y is equal to 7. So an important thing to remember is basically what constant that you do have to multiply so that the two terms can cancel each other off. That is one. And the second thing that you have to remember is, okay, if the signs are different, now in this case one of them was negative 2y, one of them was positive 2y. That is the reason I added the two equations. If the signs were the same, that is if it was 2y and the bottom one was also 2y, then I have to subtract the equations, okay? So different signs you have to add, same signs you have to subtract, right? So you must remember which, basically there are few things to take into consideration when you are doing elimination. That is, number one, what do I have to multiply by so that the number in front of either the x or the y, it can be any one that you choose, has to be the same. And after it is the same, you have to look at the signs and decide whether you are adding or subtracting, right? And that brings us to the end of the short lesson on simultaneous equations. Let us look at some problems. Alright, so we're going to finish off with some questions. So to begin with, for these two expressions, I'm going to multiply the first expression by 3 and the second expression by 2. This will make sure that both my expressions will have 6x in them, and this will become 15y is equal to 27, and this will become 4y is equal to 16. Once we have that, we can then think about whether we want to add or subtract. Now you can see that you have the same signs for both. So if you have the same signs, you have to subtract. So 15 take away 4y is 11y, and then 27 take away 16 is also 11. So y will be equal to 1. And remember, that's not all. Then you can take the first expression, substitute 1 as your y, and then this is going to be 2x is equal to 9 minus 5, which is 4. So x is going to be 2. So therefore x equals 2, y equals 1, and that is now option number 2 for us. Alright, this one. Okay, so I'm going to use the substitution method here. So I'm going to make x the subject. So this will be x is equal to 7 minus 3y, and then I'm going to substitute the instead of x, I'm going to substitute this particular expression. So 7 minus 3y plus 7y is equal to 19. Then this is going to be 4y is equal to 12, y is going to be equal to 3, and x is equal to 7 take away 3 times 3, and that is 7 take away 9. So x is equal to negative 2, and therefore the answer is number 4. And that brings us to the end of this lesson on simultaneous equations. Do tune in for the next one. Subscribe us now for more videos and content.